Okay, so let's quickly go through this ARP address resolution by ARP and address configuration by DHCP. The address resolution is about translating between the hardware address and software address. For example, you might have a host name, and then from host name you need to know the IP address of the host. So that's a translation. And actually, this is done by DNS, domain name system. But DNS is not covered here. It's covered in chapter 6, within the application layer. So DNS, this is by DNS, and DNS is the fundamental application layer protocol. And then if you have IP address, you want to translate into Ethernet address or wireless LAN address, the MAC address. So you need to translate into this, and this is done by ARP. So from host name to IP address, from IP to MAC address. But you can do the translation in the reverse way. If I have MAC address, can I know the IP address? Yes. That's called reverse ARP. If I can know the IP address, can I know the host name? Yes, you can do that by asking DNS, and that's called reverse DNS. So both can be done, in the reverse way. So, but now in this chapter we only look at this kind of translation, but between IP address and MAC address. Okay, we'll look at only the translating IP address to MAC or MAC to IP. And let's look at how to translate the IP address to MAC address first. Okay, if you have IP address of a host or a station or router, if you have the IP address and you want to know its MAC address, so what you do is that you send an ARP request, and that ARP request is in broadcast mode. It's broadcast on the subnet. Then all nodes on the subnet would receive the ARP request since it's a broadcast message. And how do you do the broadcasting on the subnet? How do you do that? You put the destination MAC address at SO1s. Then it's a broadcast frame. Then every station on the subnet will receive it. But only the target node would send an ARP reply. Who is the target node? Well, the station with that particular IP address. The station with that particular IP address in the ARP request would reply with an unicast ARP reply. Then the source station or source node would receive the reply and get the MAC address of the target node. Okay, so that's easy. And if you got this MAC address, then you put it into a cache. You put it into your cache so that next time when you need it, you don't need to ask. You don't need to send ARP again. And that cache, of course, needs a timer which would expire. So you might have a cache entry that would expire. Here's the protocol format of the ARP protocol. As you can see that you would have the sender hardware address, sender IP address. So this is 6 byte 6 byte MAC address, which is 48-bit long, but the IP address will be 32-bit long only. And then target MAC address, and then target IP address. So if I'm sending an ARP request, I would send my MAC address here. That's me, and also my IP address here. And then I would put the target IP address here, but this as null, because I know the IP address, but I need to know the MAC address. So so in the reply, it would fill up this field. I mean the hardware address of the hardware address with this IP address. So I'm sending the ARP request, and I fill up the IP address of the target, and the target host would reply and fill in the MAC address. So when I receive it, I know its MAC address. Okay. So the hardware address type, if this is Ethernet, there's a number that stands for Ethernet. If it's wireless, then there's another number. So that stands for which link protocol. Okay, and then the upper layer, the protocol address type, which if it's IP, then you fill in this number. And length, for IP, it's 4 bytes. For MAC address, it's 6 bytes. So you got the header field fill up according to this. And then if it's ARP request, you send the operation as 1. You fill it up as 1, or if it's ARP reply, you fill up with 2. If it's reverse ARP request, it's 3. Reverse ARP reply, 4. Reverse ARP means now you know the MAC address, but you need to know the IP address. That's called reverse ARP. But if it's forward ARP, it's you know the IP address, but you need to know the MAC address of the target. So if I'm sending an ARP request, I know this is mine, and this is the target, but I only know the IP address, and I need to know the MAC address. So I would fill up in this way. And then you encapsulate the IP packet. This is IP packet. Okay, you encapsulate into Ethernet frame or wireless LAN frame. And of course, it's a broadcast frame. So you would have a destination MAC address of all ones. For the forward ARP, we know why are we doing forward ARP. We have mentioned that several times. If I want to send a packet to a host which is in the same subnet as then I will send it directly without sending to the default router. But in order to send the frame to the destination host directly, I need to know the MAC address, because I'm sending a frame, and that frame needs to be filled up with destination MAC address. So I need to know the MAC address of the destination host. Then I will send ARP request. And if the destination is not in the same subnet as it's not in the same subnet, then I will send a packet to the default router, right? But I know the default router, the IP address of the default router, I know that. But do I know the MAC address of the default router? No, I don't. So I need to send ARP request. So I'm using ARP request to ask the default router what your MAC address is. Okay, and since I broadcast, so the default router would receive it, because the default router is also has an interface on this subnet. So it would receive it and then reply with its MAC address. So I would know the MAC address of the default router. So that's the reason why we use ARP. How about our ARP? Why do we need to know? In what situation we would have the MAC address but don't know the IP address? It happens when a station, a host, is diskless, meaning a station has no disk. It happens when the client host is simplified, so simplified that it has no disk. So it has no place to store its IP address. We know that the IP address is stored on the host. The IP address is stored on what? On a configuration file. It's on a file. And the file needs to be on the disk. But since this host has no disk, so it has no place to store the IP address. So what happens is that I am a diskless station, and I know my MAC address because my MAC address is on my interface. So I can issue some codes to find out my MAC address, but I don't know my IP address. But on this subnet, there is supposed to be one station, which is called RARP server. There should be a server who has my IP address. It has my IP address. So I would send an RARP request, which is also a broadcast frame, asking, okay, here's my MAC address, and who has my IP address? I don't have my IP address, and who has my IP address? Please tell me my IP address. So this RARP server will then reply with the IP address. So then I would be able to know my IP address. But what happens if there is no such an RARP server on this subnet? Then you would need to, because you need to cross the boundary, the subnet boundary, then you need to rely on the router. So then there's a protocol called bootp, which is very similar to RARP, but it's not. Bootp says that a bootp server can provide you with your IP address. However, you need to use bootp protocol, which run on top of UDP to cross the subnet boundary. So you need to ask you use the bootp protocol to ask the bootp server about the IP address. So that's when you have no RARP server on the subnet, and you need to cross the boundary to ask, and you need to use bootp protocol, which run on top of UDP, and you ask the bootp server. The bootp server would reply you with your IP address. Okay. Or another way around, we could have on the router there is a RARP proxy. You need an RARP proxy who can, even though there's no RARP server on this subnet, the RARP proxy would then handle it for you. even though he cannot, this IRP proxy does not hold your IP address, it would forward for you. I mean, for your IRP request to an IRP server on another subnet. So if I'm asking who has my IP address with IRP request, and there's no IRP server, but there is an IRP proxy on this router, on the default router, then it would forward the IRP request for me onto another subnet. And that subnet, if there's an IRP server, that IRP server will reply to the IRP proxy on the router, and the router would forward it back to me. So I will be able to know my IP address. So either in a straightforward condition that you have an IRP server on your subnet, then fine, done. If not, then you either need to rely on IRP proxy on the router, or you need to use BootP protocol, which would cross the boundary of the subnet to ask for your IP address.